A very good morning, students. Today we'll be learning about the local winds. Besides major wind systems of the Earth's surface, there are certain types of winds, even though on a much smaller scale, which are produced by the topographical peculiarities or the local temperature differences. These are mesoscale winds and are put in the category of the tertiary circulation. Since these wind systems are generated by purely local factors and their zone of influence is quite limited, they have been classified as local winds, quite distinct from the large macro-scale global circulation. Their vertical extent is rather limited to only a few thousand meters. Such local winds have their individual characteristics and they are given different names in different localities. Some of these local winds have gained notoriety for producing very oppressive weather, while some of them have a salutary effect on the local weather. Although these local wind systems are of little climatological importance, they play a significant role in the weather and the climate of a particular locality. Besides, these winds are important in various ways insofar as their influence on the plants and animals of the locality is concerned. After going through this lesson, you will be able to understand local winds and their types. Types of the local winds. Periodical. The winds originating from the diurnal temperature and pressure variation are known as periodical, and they generally complete their cycle in a day or 24 hours, like land and sea breeze and mountain and the valley breeze. Non-periodical. Only present during a season and are classified as hot and cold winds. Land and sea breeze. The only difference between the land and sea breeze in the monsoon is that the former is generated by the diurnal variation of pressure, while latter, that is the monsoon, is generated by the seasonal variation of pressure, and due to this reason, the land and sea breeze are sometimes known as diurnal monsoon sea breeze. The sea breeze develops along sea coasts or large inland water bodies when the land heats much faster than the water on a clear day and a pressure gradient is directed high over the water to the flow over the land. The impact of sea breeze rapidly declines landward and the impact is limited to 50 kilometers. Land or sea breeze system is very shallow as the average depth of the land and sea breeze varies from 1000 to 2000 meters in the tropical regions, and over the lakes the depth is even lesser. Sea breeze brings cool marine air and thus helps in moderation of the coastal temperature, and due to the sea breeze, coastal regions record a drop of 5 to 10 degrees Celsius in their temperatures. It also frequently causes late afternoon rainfall in these coastal areas, particularly during summer. The sea breezes become operative from 9 to 10 am in the morning and can remain operative till 8 pm during summers, and they reach their maximum intensity in the mid-afternoon when their velocity ranges 10 to 20 km per hour. During the evening and morning, when the temperature contrast between the land and sea is at minimum, the sea breeze dies down as the intensity of cool breeze is directly proportional to the thermal contrast over the land and sea. Due to the location near the lakes, places experience the lake effect, like Chicago. Due to its location near a lake presents a typical example of lake effect where the lakeside areas are cooler than the much warmer outlying areas in the summer. Land breeze. At night, reversal of the sea breeze may occur, but with somewhat weaker characteristics as the temperature and pressure gradient are less steeper during the night. During night, land breeze is established since land cools to a temperature lower than the adjacent water, setting up a pressure gradient from the land to the sea. The horizontal and vertical extent of the land breezes is also lesser compared to the sea breeze. Land breeze helps in the moderation of the temperature of a coastal area during the night time as it maintains regular circulation. Land breeze usually attains its maximum intensity in the early morning hours and dies out soon after the sun's up. The significance of the land and sea breeze. They help in the coastal navigation in case of small crafts. They bring greater relief to the inhabitants of those areas by reducing the temperature and humidity. Mountain and the valley breeze. These winds develop over areas with large differences in the relief and majorly caused by the temperature gradient that exists between the mountain slopes and the valley. Valley breeze. Due to the intense insolation during the daytime, the slopes of the mountains heat up rapidly, but the free atmosphere above the lowlands is not heated to some extent, as the valleys receive comparatively lesser insolation. So, relatively high pressure sets up in the valleys, while along the mountain slopes, due to more heating, the warm air is uplifted and low pressure sets up. Thus, the air moves from the valleys towards the slopes, that is a high pressure to the low pressure, and thus upslope movement of the air is known as valley breeze. Valley breezes are also known as the anabatic wind. Valley breeze is generally more intense and more persistent, and on occasions these breezes reinforce the prevailing winds on the windward slope of the mountain and cause heavy orographic rainfall. Weather associated with the valley breeze. This type of upslope winds in the mountainous region may cause occasional and afternoon thunder showers on warm and humid days. Sometimes the valley breezes are also accompanied by the formation of cumulus cloud near mountain peaks or over slopes and escarpments. Mountain breeze. On the mountain sides under the clear night sky, the higher land, that is the upslope land, radiates heat and is cooled, and in turn cools the air in contact with it. The cooler, denser air flows down the mountain slope due to the pressure difference, since the valley is warmer and at relatively lower pressure. This flow of air is termed as a mountain breeze, and they are also known as katabatic wind. Weather associated with the mountain breeze. By the morning, the mountain breeze produces temperature inversions and valley bottoms become colder than the mountain slopes. Thus, valley floors are characterized by frost during the night, while the upper part of the hillside is free from frost in the cold areas. Frequency. Mountain breeze is more common in the cold season, while valley breeze has a greater preference for the summer season. In summer, the valley breeze continues even after the sunset, and sometimes they persist throughout the night. Hot local winds. We have discussed few of the winds here. Hot local winds are produced generally by the mechanism of downslope compressional heating, also known as adiabatic heating. Examples of the hot local winds include Chinook, Harmattan, Fawn, Sirocco, Nor'wester, Brickfielder, Khamsin, Santa Ana, Lou, etc. Chinook. These are warm and dry winds blowing on the eastern slopes, that is the leeward side of the Rocky Mountain. They are a result of the adiabatic heating which occurs due to the downslope compression on the leeward side, as the mountain barrier creates frictional drag which tends to pull the air from the higher level down on the leeward, and air forced down is heated adiabatically, and at the same time its relative humidity is also lowered. The temperature in the Chinook is so warm that it can remove the underlying snow cover or ice, and sometimes these winds are so dry that in spite of their below temperature, freezing temperatures, the entire snow cover on the ground disappears by the process of sublimation. Thus, these winds are also known as Chinook, which literally means snow eater. Chinook leads to the meltdown of the water, and due to the sudden rise in the temperature, the water is evaporated. Thus, there occurs a reduction in the soil moisture, which is a negative aspect of the Chinook. Weather associated with Chinook. Ordinarily, a Chinook wind is accompanied by cyclonic activity which produces cloud and precipitation on the windward side of the Rocky Mountain range. The latent heat released into the air through the condensation process warms the air, and which passes across the mountain range, and since the air has lost its moisture, it becomes drier. During winter, Great Plain of the North America are very cold and frozen. Chinook, with its arrival, increases the temperature and brings relief to the people, and at the same time, the rise in the temperature due to Chinook also helps in early sowing of the spring wheat in the United States. Fawn. Fawn is a dry and a warm wind resulting due to the adiabatic heating on the leeward side of the mountain range. These winds are more common on the northern side of the Alps in Switzerland, and with the arrival of these winds, there is a rapid rise in the temperature. The low relative humidity and the high temperature are due to the adiabatic heating of the downslope winds. Fawn winds are present throughout the winter. Due to the presence of such winds, the temperature increases and valleys of Switzerland are called climatic oases during the winter season. Santa Ana. Santa Ana is a dry and warm local wind that occurs in the Santa Ana Valley of Southern California, and it is almost similar to the Chinook or the Fawn with regard to the thermal and moisture characteristics. Unlike Chinook or the Fawn, Santa Ana blows as an air channel through east-west, stretching Santa Valley, and due to descent over the western slope of Rockies, they become even more hot and dry. Santa Ana winds are so dry and warm that they pose a great danger to the Californian orchids and are considered as climatic hazards since they desiccate the soil and the vegetation moisture and may even result in the widespread forest fires. Harmattan. These hot and dry winds originate from the Sahara Desert and blow towards the Guinea coast of Africa. Due to their journey over the Sahara Desert, these winds become extremely dry, and as they pass over the Sahara Desert, they pick up more sand, especially red sand, and turn dusty. As these winds arrive on the western coast of Africa, the weather, which is warm and moist before its arrival, turns into pleasant dry weather with low relative humidity, thus bringing great relief to the people. Due to this reason, they are also known as the doctor winds in the Guinea coast of Western Africa. Sirocco is the warm, dry, dusty local wind that blows from the Sahara Desert of the central Mediterranean, southern Italy, and may even reach Spain, etc. As the Sirocco descend through the northern slope of the Atlas mountain, they become extremely warm and dry. These winds carry red sand particles from Sahara, due to which they cause red color rainfall in the southern Europe, and this rainfall is known as the blood rain. Sirocco is so much laden with sands and dust that the atmospheric visibility reduces almost to zero, and they are much injurious to the agriculture and fruit crops. Sirocco winds are known as the Levech or in Spain, and Leste in Morocco, and Madeira Gibli in Libya, Chile in Tunisia. Khamsin. These are warm, dry, dusty, containing sand particles, local winds that blow in northern Africa, Egypt, and Arabia. The temperature of these winds varies from 38 degrees Celsius to 49 degrees Celsius, and this is even more vigorous during the late winter and early spring. These dust storms occur on the forward sides of the temperate cyclone wherever any such cyclone passes through the Mediterranean. Simoom is the intensely hot, dry and dusty wind in the Arabian desert, and they come into origin due to the warm tropical continental air masses. These winds produced very unpleasant weather. Dust devils. Dust devil or the whirlwind form over the hot, dry land due to the intense daytime convection and surface friction. The dust devils are funnel shaped and thus resemble a tornado in the appearance, and sometimes it is so powerful that it can uplift the loosely fixed roofs of the houses and small lighter vehicles. Lu. It originates from the Thar Desert and has northwesterly to westerly direction. They dominate during the early summer in the months of March to May and create heat waves like conditions in the northern India and the adjoining parts. They have desiccating effects and are considered as environmental hazards. Cold local winds. Cold local winds are dust-laden winds, and as they have a temperature below the freezing point, they create cold wave condition. Examples of the cold local winds include Mistral, Bora, Northers, Blizzard, Parga, Lavender, Pamperu, Baise, etc. Mistral is a cold and dry wind that blows in Spain and France from northwest to southeast direction, mostly occurring during the winter months. Due to the presence of the Rhone river, these winds are channelized into the Rhone valley, due to which they become extremely cold. As they pass through the narrow Rhone valley, they turn into the stormy northerly cold winds, and their average velocity, which is 55 to 65 km per hour, may even reach 128 km per hour. Such stormy cold northerly winds cause a sudden drop in the temperature to below the freezing point. Bora. These are cold and dry northeasterly winds that blow from the mountains towards the eastern shore of the Adriatic Sea. Bora is more effective in the northern Italy, since here it descends the southern slopes of the Alps, although due to descent it gets adiabatically heated. Still, its temperature is very low in comparison to the coastal areas, and these are typical examples of the fall winds. These winds blow with strong gusts with velocities in the range of 128 to 200 km per hour. Bora has often associated with the passage of temperate cyclone, and at times the Bora winds themselves attain the hurricane force at the foot of the mountain and may cause disastrous impacts on properties. Blizzard. Blizzard is a cold, violent, powdery polar winds picked up from the dry snow from the ground. They are prevalent in the northern and the southern polar regions, Canada, United States, Siberia, etc. Due to the absence of any east-west mountain barrier, these winds reach the southern states of United States. Due to the snow and the ice particles, the atmospheric visibility reduces almost to zero, and the temperature is reduced to sub-freezing levels. Such blizzards are common occurrences in the Antarctic, and here the wind velocity may even reach up to 160 km per hour. Levanter. These are strong easterly, moist and damp winds in the southern Spain and the Straits of Gibraltar. These winds are more frequent in the early winter to late winter and cause foggy weather. Pampero. It's a northwesterly cold wind in the Pampas of South America, and it is similar to the northers of the North America and Siberia. Pampero is more active during the winters, and off the coast of Argentina, it blows from July to September. Buran. It's an extremely cold northeasterly or easterly wind that blows in the central Siberia and eastern Russia. Other local winds, snow-laden cold winds blowing out from the Russian tundra, are named as Parga. On certain occasions, these local winds are very intense and violent. With the onset of these winds, the coldest weather is experienced in the affected area. In France, extremely cold winds occurring in the winter called Baise. In southern Spain, they are known as Levanter, which is strong easterly wind of the Mediterranean, particularly in the Strait of Gibraltar. It produces damp and foggy weather. Norther is another cold northerly wind which occurs in the winter over the region from Texas southward across the Gulf of Mexico and the Western Caribbean. These winds originate from the winter anticyclones prevailing over the southern United States. Similarly, the northwesterly cold wind blowing from the Pampas of South America is called the Pampero. Off the coast of Argentina, it blows from July to September. Sometimes dust storms accompany these strong winds, which under favorable conditions may yield precipitation. During the colder part of a year, a strong to violent northeast wind blows in the Gulf of Papagayo on the northwest coast of Costa Rica and in the adjoining Pacific coastal water. This local wind is called the Papagayo after the name of the Gulf. Tepeser is still another local name given to the strong northerly wind blowing in the southern Mexico and northern Central America. Friajem of the Amazon Valley and the Habub of Sudan are similar cold winds of local origin. The onset of these local winds lowers the temperature considerably. Such winds may persist for 3 to 5 days. Besides the above mentioned local winds, there are a few more such as cat's paw, cordonazo, grigale, chubacaba, etc., which blow in various parts of the world under different local conditions. Some of the local winds may be warm, while others may be cold and dry. Some are associated with a warm air mass, while the others may be of cold air mass type. It may be mentioned out that these local winds are invariably associated either with a cyclone or an anticyclone. Wherever be the case, they have a great impact on the weather and the climate of the locality they visit. All the cold winds which originate when a large mass of cold air accumulates over the high and the air descends into the valley and lowlands are descended as a gravity winds or katabatic winds or fall winds or drainage winds. In different localities, they are given different names such as Mistral, Bora, Villiva, etc. All of these winds are in fact downslope winds. The local winds that are extremely hot or cold affect the environment in various ways. They exert a great stress on the animals as well as vegetation. They also transport atmospheric pollutants from one region to the other. But there are certain categories of local winds like the sea breeze and the land breeze that are most welcome features of the environment for the people living in the coastal areas. Summary. Local winds are produced due to local variability in the temperature and the pressure conditions. Thus, they are more localized in their extent and cover limited horizontal and vertical dimensions and confined to the lower levels of the troposphere. However, it is important to remember that some of the local winds can have very large dimensions like the northern of North America, which originate in the Arctic Canada and reach as south as the Gulf of Mexico.